Hey everyone, in this video we're going to be talking about increasing and decreasing intervals for this part of attributes of polynomials. Okay, this is another characteristic of polynomials of what makes them so unique when we start looking at the in between those endpoints, right? What happens between the function? How does it behave? How does the function change? How does it change directions? And how does it increase or decrease? So let's get right to it. To identify interval, right? Another word for interval is really just a range of values or like a section in the graph when something is happening. So we're looking for increasing or decreasing, and those words really mean to go up and to go down, right? To increase means to get bigger, and to decrease means to get smaller. So the best way to think about this, right? The way I like to do it is I'm going to draw just a simple graph. Let's say we have just a parabola. Let me center this a little bit better. That's not centered. Here we have a quadratic, right? Now this point that I'm going to identify it as a minimum, and it's going to be centered at 1, 2. Let's just say it's 0, 0, -3. So what I'm really analyzing here in this graph is I'm trying to figure out when is the function increasing and when is it decreasing. Okay, so what I like to do is I like to start on the far left-hand side, and I like to just trace the graph with my pencil. If my pencil is moving downward, that part of the graph is decreasing. Notice how I get to the minimum and it starts changing directions again. As the pencil goes upward, now that part of the function is increasing. So what's really happening is we're looking at the x values. Over here we have -infinity, over here we have +infinity, and I'm going to say that from -infinity all the way to 0, the graph is decreasing. Ooh. And then because the graph at 0 starts to move towards the right, we're looking at just the x-axis. So from -infinity all the way to 0, the graph is going downward. And then from 0 to the right, the graph is going to start to go upward or increase. Now, as we progress, we're going to have more loops and turns and changes in directions. So there's going to be more intervals where it increases and decreases. The only thing I would change here is my mistake. I should have put a bracket around these because it actually includes the value 0. So we're really just describing an interval or a set of x values that as the function is approaching this certain direction, what is happening to the graph? It's decreasing. And then it gets here to 0, right? From 0 to the right, the graph starts to increase. It starts to go upward. And yeah, let's do a few examples to see what we're talking about. Here we have a polynomial that is an even degree polynomial because both arrows are pointing down. And we're going to identify when it's increasing or decreasing. I'm going to label increasing as green and then red as decreasing. So I start on the far left-hand side and I trace the graph. On the left, I start moving upward. Since my pencil is going upward, this is going to be an increase. I'm going to put a plus. At every maximum and minimum, the graph is going to change eventually directions. As it changes directions, now my pencil is moving downward, so this is a decrease. I reach the minimum value, and the graph starts to change directions again. So as I move my pencil upward, I make this a positive increase. And then the graph goes downward, and I have a negative or a decrease. So there are two ranges or parts of the graph where the graph is going up, and there's two parts of the graph when it's going downward. So how do we label these locations? Where is it increasing? Well, remember we're starting here on the left-hand side from -infinity to +infinity. So from negative infinity all the way to negative 3. We're looking at just the x-axis. Okay, so from negative infinity to negative 3, the graph is going up or increasing. Put a union. And then from negative 3 to negative 1, the graph is going down. So from negative 3 to negative 1, it's decreasing. And then from negative 1 all the way to positive 4, the graph is going upward. So from negative 1 to 4. And then finally, from 4 all the way to the right, the graph is just going to keep going downward. So it's going to decrease from 4 to infinity. The graph is just going to go to the bottom. And this is really what we're talking about when we're talking about intervals. These are intervals. This is a section in the graph and another section in the graph when it's going upward, when it's increasing. And then here we have two sections in the graph when the graph is decreasing. Later, we'll talk about increasing and decreasing velocities, right? As you get to pre-cal and calculus, these intervals will actually represent velocity or speed or what happens as time progresses, right? Well, this is when the roller coaster slows down, or this is when the rocket speeds up, that kind of stuff. Okay, for now, just identify the increasing and decreasing intervals. So let's do one more example, and then we can call it a day. I strongly suggest you to pause the video right now and give this one a try. See if you can identify the increasing and decreasing intervals, and then press play and see if we both got the same answers. Again, I'm going to start on the far left-hand side of the graph. Notice how the pencil is moving downward. So as I reach this bottom part, I got the wrong color. As I move downward, this section of the graph is decreasing. And then the graph changes direction at the minimum value and it starts going up. And it's increasing. As it peaks, reaches a maximum value, it starts to change directions again. So it decreases. And then it increases again. It starts moving upward. When it hits that peak at the very top, that maximum, the local maximum, it starts to decrease from there forward. It's a minus. Remember, we're looking at the x values only. What happens to the x-axis as it goes from negative infinity all the way to positive infinity? So only focus, right, when you're looking at this, focus specifically, and I'll highlight this in yellow, on the x values only. Because we're looking at the x-axis. What is happening to the x-axis as it goes from negative infinity to positive infinity? And as the x values are controlled, as the input is controlled, the output will go up and down, right? So we're talking about the increasing and decreasing intervals as we talk about the x-axis and the x values. So increasing, where is it green? I notice that it's green from negative 5 to negative 2. That's my first gap in the middle that it's increasing. It's also increasing from 0 to 3. Right? From negative 5 to negative 2, it's going to increase. And then from 0 to positive 3, it's going to increase as well. Those are my two increasing intervals. I look at my decreasing intervals, and I have 3 locations where the graph is going down. So I start at negative infinity to negative 5. Remember, just the x values. And then again at negative 2 to 0. And then finally from 3 to positive infinity. I never put a bracket around infinity or negative infinity because we'll never actually get there. So it doesn't really include them. So notice how from negative infinity to negative 5, the graph is going downward in this section right here. And this range of values, in this interval, the graph is going down. Then from here to negative 2, the graph is going up. And then from negative 2 to 0, the graph is going back down. From 0 to 3, the graph increases again. And then from 3 to infinity, the graph just goes all the way to the bottom. And that's how we identify an increasing and decreasing interval. I hope this helps. Please let me know if you have any questions. And as always, we'll calculate.